In part two, I tried to provide a video where people can understand the constructs, the general constructs, and the general terms of the theories. Now, for CDST, this is a bit tricky because to explain it in a linear way, it often doesn't work because you need one concept to explain the other. But I understand that you've worked hard to make this into a linear presentation, so I'm quite excited to see that. So what would be the first concept that we would need to understand?
I'm just going to go right through the whole thing and see if I can convey the terms, Cesar, that you have chosen, and you've chosen them well. And although I introduce them one by one, because I can't do otherwise, it's their combination. You have to remember that it's their combination. That's a signature of a complex system. So, first of all, a system. A system is a set of things. It can be people, it can be cells, it can be a lot of things that interconnect in a way that they can achieve something together. A system can be simple, it can be complicated, it can be complex. A simple system might be a thermostat. You always get predictable, provided it works, you get predictable results. If you raise it up, you heat the environment better, at least in this temperate environment. If you put it down, it turns the heat off. Very simple, but it's a system. It's interconnected. A car engine is a complicated system. It has many parts. They interact also to drive the car forward or reverse or whatever direction you want to put it. But notice that the functioning of the whole system is understood by understanding the contribution of each part. And it can be broken down and reassembled in the same way. And if it is, then you'll get the same result, a predictable outcome. A complex system, on the other hand, is different because the interaction among the elements can lead to emergent, unpredictable behaviors. In the case of language, which is a complex system, the system consists of multiple speakers making meaning. The speakers interact with one another, and the structures of language arise from this interaction and from the interdependence of the patterns of experience, the social interaction, and embedded cognition. It can't be reversed engineered. You can't replay it in a way and take it apart. It's an organic whole. In the same way, by the way, the brain is also a complex system. There's a lot of interconnectivity in the brain that gives rise to new patterns. We can isolate a certain part of the brain and say this is for audition, but it connects with everything else in order to give us meaning for what we hear. Complex systems are open. They're open to the environment. They take in and expend energy, matter, or information, depending on the type of system. Complex systems are perpetually dynamic. And James Blake wrote, they are becoming, not being. They can undergo periods of relative stability, but even when the system settles down into certain attractors or attractor states, even when the system settles down like the stream water that becomes still, there's still no stasis. And the system has the potential to undergo radical change at any time. It's a tenet of dynamic systems theory, as a matter of fact, that dynamic systems must lose their stability in order to shift from one stable attractor state to another. When patterns are very stable, there are no opportunities to explore and reassemble new solutions, writes Esther Phelan. Emergence, very important concept, CDST, in complexity theory. Emergentism is the spontaneous occurrence of something new, says Paul van Geert, that arises from the interconnectedness, the interdependence of the components of the system while it's interacting with its environment. Furthermore, these patterns are said to self-organize without direction from external factors and without a plan of the order embedded in any individual component. That's from Mitchell at the complexity mecca, Santa Fe. So the examples often used come from nature. We talk about bird flocks or ant colonies or termite mounds. And what we mean when we say they self-organize is that the individual ants or birds or termites don't have a blueprint. They don't have a master plan. It's through their interaction locally with each other that incredible structures arise. A flock of birds or a termite mound is incredible architecture, but there's no architect. There's no central authority. There's no blueprint. These systems, these structures emerge. Now, coming closer to home, we might think in terms of a language pidgin. I guess I should say P-I-D-G-I-N. Since I'm talking about animals, I don't want to confuse it with a bird, but think of a pigeon, or later its development into a Creole, as the expressive needs of the pidgin speakers is exceeded by the language resources available. Another example of a pattern might be the IRF pattern, that comes from emerges from classroom discourse. So the teacher initiates, that's the I, right? Student response, that's the R. Teacher feedback, that's the F. The IRF pattern seems to occur all over the place. That's been attested to for a long time. Such a pattern emerges from the need for the teacher to keep control while at the same time providing a learning opportunity for his or her students. In SLD, an example is the U-shaped developmental pattern, which exists among competing forms in and into language. The patterns emerge not only from the language of the environment and not necessarily from an innate blueprint, but rather from the creation of order. Of course, the language system is immanent in the speakers, but macroscopic order arises from microscopic behavior of language speakers. Nonlinearity. The effect is not proportionate to the cause. So an example from Laufer and Mura on vocabulary learning, and this has been attested to for L1 learners as well, but their work was on L2 vocabulary learning. It begins quite slowly. The acquisition of vocabulary in the second language begins quite slowly. But once a certain number of words are reached, learning increases at a very fast rate until vocabulary reaches a certain level that seems to serve the student or learner well enough, and then the rate of learning slows down. So vocabulary learning, vocabulary size, does not increase linearly over time. Adaptation. Complex systems are also adaptive. An adaptive system changes in response to changes in its environment. Complex systems maintain stability by adapting to change, and successful adaptive behavior entails the ability to respond to novelty. An example in language learning is what Lynn Cameron and I called co-adaptation between interlocutors. Susie McQueen talks about adaptive imitation. Co-adaptation suggests that causality goes in both directions. Change in one system leads to change in another, and the mutual influence continues. For instance, Dale and Spivey showed how a child and his or her caregiver produce sequences of words or phrases during a conversation that match those being heard. So the caretaker imitates the child imitates the caretaker. Not exact imitation, mind you. That's why I like the term adaptive imitation. But it's a process they call syntactic coordination. We know that in second language acquisition, co-adaptation also takes place between conversation partners. Earth showed us this a long time ago, and presumably between teachers and students. And as this co-adaptation, this back and forth and matching process happens, not exact matching, but some kind of synchronized behavior occurs, I think that enhances the possibility that learners receive an optimal sample of language from which to learn. Reciprocal causality. Emergent patterns entrain those that rise subsequently in a mutually constitutive process that Lynn Cameron and I referred to as reciprocal causality. Some researchers call it circular causality.
Mhm.
Notice I'm talking about emergence, right? The patterns emerge from the bottom up through the interaction of the interlocutors. So there's a local to global process of emergence. Reciprocal causality suggests, but there's also a process of constraint. That is not only global, not only local to global, but global to local. And why is that important? Well, the constraints, first of all, can be due to the historicity of the system or the social norms, the normative social behavior. But it has to happen in order to keep language from emerging and dialects and individuals becoming mutually unintelligible, right? There has to be some kind of check. So it's a kind of circular process, emergence and then constraints or restraints that keep the system from spiraling out of control and keep language mutually intelligible. Pedagogical change takes place at every direction, not just hierarchy, where top controls bottom. In fact, there's nothing controlling in a complex system, and attempts to control it can sometimes lead to unintended consequences. Unfortunately, we have many examples of that in our history. Instead, development is seen as a complex process of dynamic construction within multiple ranges in multiple directions. Bishop et al. This view of development might be better served of conceiving of language as a web rather than a developmental ladder.
One idea that I think many newcomers into the theory may find confusing is the idea of attractor states of relative stability. Perhaps in reductionism, we think of stable things as being essentially stable, or things don't change. For example, genetics used to, in the past, determine everything. Now we know that that's not the case, that there is epigenetics, the influence of environment in gene expression, all of that. But when it comes to attractor states, I mean, how is it possible that we could have relative fixedness or relative stability?
So, so as I said before, stability doesn't mean stasis. Another image that complexity theorists use is the idea of hills and valleys, a landscape filled with hills and valleys, and a ball rolls around this landscape. In some cases, it falls into a deep hole, a valley of some sort from which it doesn't emerge. In other cases, it's poised at the top of a hill or a mountain, and it can go in various directions, east, west, north, south, and some variation of that. And so it's this system that roves around the landscape. Now, when the ball falls into the well, into a valley, we would say, aha, it's a fixed point attractor. That is, it's an attractor that bottoms out. And some people would say that's where fossilization resides, where something seems to be stuck, right? It's down in this deep well.
Yeah.
However, remember that in complexity theorists, and maybe it's because of my disposition, but there's always a prospect of change.
Mm-hmm.
So it's always possible for the ball to emerge from the deep well. And I don't really want to get into fossilization. It's a whole other story, but basically nothing is permanent. Nothing is completely closed down.
Yes.
As Marco Long says, you really can't even say something is fossilized until the person has passed, because during their entire lifetime, there's always a chance that the pattern will break up, the fossilized pattern will break up and emerge. There's no question that the L1 has an influence on the L2, but it's not static. There's nothing essentialist about the system, right? It's always poised to change.
Yes.
And certainly as a language researcher and as a language teacher, it seems to me that's a philosophy you want to hold on to.
Mm-hmm. Yes. Yes. Another thing that may be perhaps confusing for people is when they hear unpredictability, etc., they think the system may not show systematic trends, but but this concept captures that essence, that there may be feedback loops, and all sorts of phenomena, self-organization that leads to these kinds of systematic trends or attractor states of periods of relative stability. So I thought it was probably important to emphasize that part.
Yeah, yeah. I actually prefer the term attractors to attractor states, because state suggests something more essential or something more static.
Yes.
So
Okay.
but I used attractor states. I'm not saying I didn't, but I prefer the use of term attractors.
Okay. So for self-organization, I think that's probably another potentially confusing term. And I think
Yes.
it's the same problem that Professors Truscott and Professor Mike Sherwood-Smith deal with when they're in their theory of processing. There is no a central processor, a central homunculus that controls everything. And so they even spent 3 chapters talking about how cognition can work without it. And so I think it's similar to the concept of self-organization in systems. Self-organization, it sounds like some sort of agency is trying to organize something because of the self part of it, but that's not at all what it means, right? It's so what?
No, if I may, I'll go back to language again and say, okay, so when I use language, I use it to make meaning. I use it for a purpose. I intentionally use it. So I have agency over my use of language. However, collectively, language emerges. Rudy Keller writes about this, the historical linguist. As you speak, Cesar, as I speak, as others speak, we're intentionally making meaning. But collectively, the system self-organizes in the same way as, Keyes economics. It emerges in the system. So the regularities come out of the collective use of language. In that sense, I would say language is self-organizing. If you just think about, some new vocabulary that might come in through the invention of some new theory or a new device. So vocabulary enters the system, and you use it, I use it, and eventually it settles into it becomes part of the system, and people use it. They tap into the system to make meaning themselves. But it's not just vocabulary. I could point to a number of grammar rules, pedagogical rules that have changed. It's not intentionally that it does. We don't engineer language. We've tried. And they tried in English to do away with the she/he or he, her, his, her distinction by creating new pronouns. It doesn't work. They don't last. So we try to engineer language, but we don't. So individuals have intention, but collectively, the language self-organizes into a system, and it changes. That's why I said I could point to a lot of grammar rules that have changed over my professional lifespan. I'm not talking about changes that have taken place 300 years ago to now. So I make a distinction between learners using language intentionally and the system self-organizing. The great vowel shift is another example. Little by little changed, and then the vowel shift occurred. That's a self-organizing thing. No one said, let's change the vowels of English, right?
Yes.
It's self-organized.
Very good. Thank you. Thank you.
Yeah.